Hello everyone, welcome to Aviation Engineering YouTube channel. Alright, so today I'm going to teach you chapter 21 air conditioning system, lesson number 5 under zone temperature control. Alright, so air conditioning system is a bit long lesson, so I think you already watched about lesson number 1, 2, 3 and 4. So if you still not watch these videos, please check the description and then go and check the previous videos, and then you come to watch this video, because then you can have a good knowledge about air conditioning system in Airbus 320, 19 and 21. All right, so and also I want to tell you, please subscribe my channel and don't forget to like my video, and also don't forget to share this video with your friends and relatives. All right, so let's go to the lesson. All right, so today's AT chapter 21 air conditioning system, zone temperature control, lesson number 5. Right, so this is called flow control and pack components. All right, flow control and pack components. Alright, so in this lesson, you will learn detailed descriptions and the operation of the flow control and pack components. Alright. Okay, so you can see here is the air conditioning system. So, okay, so let's go to the first one, ozone filter. All right, so you can see here is the ozone filter, right? So from the bleed air system, I mean, the air will come through the bleed air systems, and this is the ozone filter. So an ozone filter is installed upstream of each flow control valve, right? So this is the flow control valve. So ozone filter is situated or installed upstream of each flow control valve. So just keep in remember. So it is used for catalytic removal of ozone from the hot bleed air supplied from the pack. Okay, so it is used for catalytic removal of ozone from the hot bleed air supplied to the pack. All right, so you can see this is the ozone filter. It is situated upstream of the flow control valve. So this air is coming from the engine bleed system. All right, okay, so this is the live view. You can see this is the ozone filter over there, right? So you can see this is the ozone filter in a 320 or 319 or 21 aircraft. All right. All right, so now let's go to the flow sensor or flow control valve. Flow sensor or flow control valve. This is the flow sensor or flow control valve, right? So a flow sensor connected to the flow control valve, right? The flow sensor is connected to the flow control valve, senses the differential pressure equivalent to the air flow through the valve inlet. All right, so this is the flow sensor. This is connected to the flow control valve, right? So it sends the differential pressure equivalent to the airflow through the valve inlet, right? So the differential pressure is transformed into an electrical signal, right? So the differential pressure is transformed to an electrical signal and sent to the pack controller for actual flow calculation. You remember, this flow sensor is taken, sense the differential pressure equivalent to the airflow through the valve inlet, and this one, the differential pressure is transformed to an electrical signal, and then it is sent to flow control, pack controller for an actual flow calculation. You can see the graph. Okay, you can see this is the flow control in the pack controller, right? So this is the flow sensor, and it is connected to the flow control valve. Then according to the actual flow calculation, right? So according to the actual flow calculation and the flow demand, the pack controller generate and flow control valve drive signal in order to control the flow control valve torque motor, right? So according to the flow according to the actual flow calculation and the flow demand, right? So the pack controller will generate and flow control valve drive signal in order to control the flow control valve torque motor. So you can see this one generate a signal to the flow control valve torque motor, right? So this signal is a drive signal, right? Okay, so this butterfly valve is electro-pneumatically operated. So this is the butterfly valve. So this butterfly valve is electro-pneumatically operated. So you can see this is the flow control valve. Okay, flow control valve is here. Right, so now the flow control valve has a shut-off solenoid. Flow control valve has a shut-off solenoid. You can see this is a shut-off solenoid which is energized in case of, all right, so this shut-off solenoid will be energized in case of engine start. If there's engine start, it will be energized, or opposite engine start provided the cross bleed valve is detected open, right? So the flow control valve reopens 30 seconds after the end of the engine start sequence, and or engine fire push button release out, or ditching push button pressed in, or applicable pack push button set to off. You can see this the solenoid. This will be energized. You can see this will be energized. Fire push button release out, ditching set to on, or engine start, opposite engine start plus cross bleed valve open. If one of these condition is open, this will be energized, or else the disagreement with the related positions of pack overheat push button set to off, also it will be energized. You can see this one. All right, so this is the flow control valve. So you can see that this is the solenoid over there, right? So this is the live weed, right? Okay, so now the flow control valve is automatically closes in case of, right? So the flow control valve will automatically closes in case of low bleed pressure, valve spring loaded to close, right? If there's a low bleed pressure, it will be automatically closes. See the valve spring loaded to close. Compressor overheat. If there's compressor overheat also, the flow control valve is automatically closes. Muscle pressure venting by means of compressor pneumatic overheat sensor. So this is the compressor pneumatic overheat sensor. All right, so this is the compressor pneumatic overheat sensor is here. You can see compressor pneumatic overheat sensor, and this signal is come from the compressor pneumatic overheat sensor, and this one is the closed. The flow control valve is here. All right. Okay, so you can see the compressor pneumatic overheat sensor connection. Here is this compressor pneumatic overheat sensor connection, and the cabin pressure connection over there. Cabin pressure connection over there. I think you cannot see it. All right. Okay, so now the bypass valve. Third one is bypass valve. So the bypass valve regulates the pack discharge temperature by adding hot bleed air to the air cycle machine for quick pack temperature. All right, so the bypass valve regulates the pack discharge temperature by adding hot bleed air to the air cycle machine for quick pack temperature. All right, so this is the bypass valve. So bypass valve, this is the bypass valve. Okay, it regulates the pack discharge temperature by adding hot bleed air to the air cycle machine, all right, for quick pack temperature. All right, so the bypass valve is electrically operated by a stepper motor. You remember the bypass valve is electrically operated by the stepper motor, controlled by the pack controller. The stepper motor is controlled by a pack controller according to the water extractor temperature, right? So this stepper motor is electrically controlled by the pack controller, and it is controlled according to the water extractor temperature. See the water. Here is the water extractor temperature sensor. Signal is coming from here. So this is the water extractor temperature sensor is there, right? So according to the signals coming through the water extractor, this will operate electrically, right? Stepper motor. So you can see this is the bypass valve, right? It is a live view of bypass valve here, right? Okay, now let's go to the ram air inlet flap. Ram air inlet flap. Right, the ram air inlet flap modulates the air flow through the exchangers in order to control the temperature of the outlet pack. Right, so this is the ram air. So it's go through the primary heat exchanger and the main heat exchanger or secondary heat exchanger, and it is exchanges in order to control the temperature of the outlet of the pack. So this is the outlet of the pack. So it control the temperature of the outlet pack. All right. So the ram air inlet flap is actuated by electric actuator, right? So ram air inlet flap is actuated by electric actuator. So this is the electric actuator, right? Controlled by the pack controller, and also this is also controlled by the pack controller according to the water extractor's temperature in order to obtain optimum pack cooling airflow. So this actuator also control by using the pack controller, and also it controls according to the water extractor temperature sensor signals. All right. So the ram air inlet flap closes during takeoff and landing. And remember, the ram air inlet flap will be closed during takeoff and landing. So you keep and remember. So you can see the live view. This is the ram air inlet. So this is the ram air inlet actuator over there. All right. Okay. So now let's go to the anti-ice valve. Anti-ice valve, right? So this is the anti-ice valve. The anti-ice valve removes any excessive ice formation across the condenser, right? So anti-ice valve remove any excessive ice formation across this is the condenser, or maintain the pack outlet temperature at a fixed value if the pack controller is unable to control the bypass valve. If we unable to control the bypass valve, the anti-ice valve will control the temperature, pack outlet temperature. All right, and it's control according to fixed value. Okay, so the anti-ice valve is pneumatically operated. Anti-ice valve is pneumatically operated and electrically controlled by the solenoid. So remember, anti-ice valve is pneumatically operated and electrically controlled by using a solenoid. Okay, you can see the solenoid, the signals will be come from the pack controller. Okay, so the solenoid energized, this solenoid will be energized, the anti-ice valve pneumatically operate as an anti-ice function, and solenoid de-energized, if solenoid de-energized, the anti-ice valve pneumatically operate as a temperature control valve, right? So it maintains a pack outlet temperature of 15 Celsius. It means if there's a fault in the bypass valve, so then the anti-ice valve is used to control the temperature, and it maintain up to 15 Celsius. So if the anti-ice solenoid valve is energized, it is act as a pneumatically operate as an anti-ice function. And if the solenoid is de-energized, so then anti-ice valve pneumatically operate as a temperature control valve, right? It maintains a pack outlet temperature of 15 Celsius. All right, so here you can see the anti-ice valve over there, right? I think you cannot see clearly, but just keep remember it is situated over there, right? Okay, now let's go to the anti-ice function is provided by two delta pressure relays, right? So the anti-ice function is provided by two delta pressure relays, right? Two delta pressure relays. Here you can see two delta pressure relays, the high and low pressure condenser flows. When the delta pressure increases, increases due to ice buildup restricting the airflow to the concerned relay, control the anti-ice valve to an open position, right? It means the delta pressure is increases due to ice buildup in the condenser, restricting the airflow, concerned relay, control the anti-ice valve and open positions, right? So the pack outlet pneumatic sensor, this is the pack outlet pneumatic sensor, right? Here you can see the pack outlet pneumatic sensor. Pack outlet pneumatic sensor is used only to modulate the anti-ice valve to control pack discharge temperature at a fixed value in case of pack controller failure. All right, you can see the delta pressure relay. This is the anti-ice valve, pack controller. Here you can see there are different kind of flow. So you can see this is the high pressure condenser flow. From red color you can see the high pressure condenser flow, and blue color low pressure condenser flow. Here is the low pressure condenser flow, and from the green color pack outlet temperature sensor tube. This is the green color one, pack outlet temperature sensor tube, right? So you can see the live view. This is the delta pressure relays, right? Here you can see the delta pressure relays. All right, okay, now let's go to the air cycle machine. The air cycle machine, which consists of turbine, compressor and a fan which cools the air, right? So this is the air cycle machine. So this is the live view. So it consists of the fan, compressor and a turbine. The main components of the air cycle machine is rotating shaft. So this is the main component, rotating shaft. A turbine, compressor and a fan are mounted along the shaft. So turbine, compressor and the fan is mounted along the shaft. All right. Okay, so now exchangers, reheaters and condensers, right? So these are the exchangers, primary heat exchanger, main heat exchanger and the reheater, condenser. All right, so the air passes through the two heat exchangers and reheaters. The air, okay, the previous lesson, I think lesson number 2 or lesson number 1, I teach you how the flow is going. So here the flow is coming from the breathe air system. This is the ozone filter, and flow control valve is go here and it's go to the bypass valve. Okay, and here is the anti-ice valve, and it's go to the primary heat exchanger, go to compressor, come here, and main heat exchanger, come to reheater, condenser. All right, sorry, reheater, condenser, water extractor, and again come to reheater and go to the turbine, and it is go to the pack outlet. All right, so the air passes through the two heat exchangers and reheaters before it enters the condenser, which drops the air temperature well below the dew point, right? So in the condenser, which drop the air temperature. In condenser, the air temperature will be dropped below the dew point. So the cooling agent for the primary heat exchanger and the main heat exchanger is outside ram air. So the primary and main heat exchangers, the cooling agent is outside ram air, right? Outside ram air, right? Okay, so the reheater is used to raise the temperature of the air before reaching the turbine, right? So the reheater is also used to raise the temperature. So when it is come to the condenser, it comes to the below the dew point, and it is go to the water extractor, because in here the water will be collected. And then if it is come to here, then reheater is used to raise the temperature in the air, right? In the air before reaching the turbine inlet to vaporize any remaining water droplets for turbine protection, right? Okay, so you can see the main heat exchanger. This is the primary heat exchangers, right? So the water extractor, here is the water extractor. The water extractor collect water droplets and drain them inside the water extractor body. Remember the water extractor, because in here the air will be the temperature of the air will be goes down below dew point. So then the water can be collected, or ice also can be generate. So if the ice builds up, then the anti-ice valve will be operated and go to remove this one, right? So then the water is there, so water will be collected, drains and collected in the extractor body in order to spray the collected water into the ram air flow of the exchangers to increase the cooling efficiency. So then the water will be taken to the here and spray to the ram air inlet, right? Ram air inlet. Why? To increase the cooling efficiency. All right, to increase the cooling efficiency. All right, so you can see this is the water extractor over there, right? This is the water extractor, right? So now the check valve. You can see the check valve. The pack downstream check valve stop leakage of air from the distribution system, right? So the pack downstream check valve stop leakage of air from the distribution system when the flow control valve is closed. All right, so the check valve is fitted to the pressure bulkhead. So the check valve is fitted to the pressure bulkhead. You can see this is the check valve. All right, okay, so that is the end of the lesson. So okay, now we will discuss about two questions. So I will ask the first question: how is the flow control valve actuated, right? How is the flow control valve actuated? So here are the answers: A, by means of stepper motor, and B, by means of torque motor, and C, by means of AC electrical motor. Okay, so can you guess what is the answer for this one? Okay, so the answer is B, by means of torque motor. I teach you in the previous, right? In the previous slides, I teach you, right? Okay, then question number 2: if the pack controller fails, the pack outlet temperature is controlled by, right? If the pack control fails, the pack outlet temperature is controlled by. The answers are the flow control valve, and B, the bypass valve, and C, the anti-ice valve, right? So can you guess the answer? All right, so the answer is answer C, the anti-ice valve, the anti-ice valve. All right, so that's the end of this lesson, and thank you for participating in this lesson number 5. So I think you gain a good knowledge about air conditioning system. Now this is the 5th lesson. So now I think if you stay with me about from the lesson number 1 to lesson number 5, so I think you got a good knowledge about air conditioning system, especially for zone temperature controlling. So I think now you know what is the function of this the components inside the pack. So you can see the flow control, ozone filter, and the primary exchanger, main heat exchanger, and the anti-ice valve, bypass valve, and condenser, reheater, water extractor, so turbine also, and compressor. So you got knowledge about how it's work and what is the function of these items. All right, so and also in future, I mean in the future lessons, I will describe more in detail about the about the components, and also I will describe what is the function, special function about these components, and what kind of metals used to prepare this one. So I will describe in future. So stick with my channel, and if you love for aircraft maintenance, so don't forget to subscribe this channel, and don't forget to share these videos with your friends, cousins, because it will be useful for him, because before they going to do the aircraft maintenance type training. And also this is very useful for someone who someone who want to join aircraft maintenance basic training, so then he can get an idea how the aircraft is working and what kind of thing he have to learn. All right, so thank you very much for joining this lesson, and please stick with me for the new videos, and don't forget to subscribe, like, share, and hit the bell icon also. All right, so thank you again, and we will meet on next video. Have a good day for all of you.